Hi friends, welcome to Code Linux. In this session, we are going to learn about processes. So, we are going to learn what is a process, what is a program, what is foreground and background process, what is a daemon process, how to initiate a process in background, how to move process from foreground to background and vice versa, how to control processes using kill command with signals. So these are all the concepts we have planned to learn. What is a process? A process is a runtime instance of a program. See, a program is a binary code which would be there in the hard disk. When you are executing the program, what happens means that binary code would be loaded to the memory, and as soon as it is loaded to the memory, it gets the name process. It gets the status process. Till it is loaded to the memory, it is called as program. It is just called as a binary program. As soon as it is loaded to the memory, it gets the name process. And the operating system provides an environment to the process. This is known as runtime environment for the process. So every process in the Linux or Unix system has got a runtime environment, a dedicated runtime environment. In that runtime environment, the code block will be there, then the data block would be there. There you would have this heap, stack. Okay, so all these things would be taken care by the operating system. So for every running process, there would be a runtime environment. So a process is a runtime instance of a program. It's an instance of a program. What do you mean by instance? Instance means an instance means what? There is a program can have any multiple instances. A copy instance can be understood as a copy. Okay, program's copy which is there in the memory. Okay, so that is called as the instance. Okay, it's a runtime instance of a program, because it would be running, the process would be running. Okay, it is there in the memory and it is either running or waiting for the CPU. Okay, what is a program? A program is a binary code present in secondary storage device. A program is dormant, it is present in the secondary storage device. Okay, but a program can always be run, and once it is run, it becomes a process. Okay, so this is the relationship between a program and a process. Next, what is a foreground and background processes? What are foreground process? What are foreground process and what are background process? A foreground process is a process that is user interactive. A foreground process is always user interactive. What do you mean by user interactive? It interacts with the user. Like it could expect input from the user. It would display output to the user. So a user interactive process always needs a terminal to run. Okay, so that is a foreground process. And what is the background process? A background process is a non-user interactive process. It is not user interactive. That is, it doesn't need a terminal. It neither expects input from the keyboard nor sends output to the monitor. So it would be running in the background without being user interactive. So that is a background process. A background process can be a non-user interactive process. So how many foreground process can a user initiate? How many foreground process? As it is a terminal dependent process, the user initiated that is foreground process can be only one. There can be only one foreground process at a particular point of time. Okay, when a user has logged in from his login shell, he or she can initiate only one foreground process, because when you are executing a process in foreground, no, so and that process needs the terminal, right? So as long as it is not terminated, it won't give back the dollar prompt. It won't give the control back to the shell. So unless and until this process gives the control back to the shell, how can the shell initiate another foreground process? That is the reason once one foreground process started. Until and unless this foreground process is terminated, another foreground process cannot be initiated. But contrasting to this, as far as background process is concerned, there can be any number of background processes, because when you are initiating a background process, okay, it would be run in the background. It won't be user interactive at all. So you can be initiating any number of background process, and they all can be running simultaneously. Okay, so this is one main difference between these are the differences between foreground and background process. Foreground process are user interactive, background process are non-user interactive. Foreground process need terminal, background process don't need terminal. Okay, foreground process, there can be only one foreground process initiated at one point of time, but there can be n number of background processes that are initiated and running simultaneously. What is a daemon process? A daemon process is a never-ending system-initiated background process. Okay, daemon process is a never-ending, not necessarily system-initiated, even the user-initiated. Okay, user-initiated or system-initiated background process is known as a daemon process. Okay, it would be basically a background process which would keep on be executing, which would be there in the memory always, unless and until it is terminated. Okay, unless and until it is explicitly terminated by the user, it would keep on be executing. So that is known as a daemon process. And how to initiate a process in the background? How do you a user wants to initiate a process in the background? How is it initiated? When a user initiate a process, by suffixing a process with ampersand, the process can be initiated in background. So when you are executing one command, and let us suppose that command is a non-interactive, that's a non-interactive command. Okay, then it is a candidate to be run in the background. So such process you can always suffix with ampersand, and thus you can run it in the background. You can put it while initiating. You can put it in the background. How to move a process from foreground to background? Okay, next the question comes. Let us suppose that there is a good candidate to be run as a background, but by mistake I have run it in the foreground. So now, is there any way of moving it to the background? Yes, there is a way of moving it to the background. Or there is a job in background, I want to bring it to the foreground. Is it possible? Yes, that is also possible. Okay, so all these things are possible. So there are commands like bg command and fg command. Okay, bg command, fg command, jobs command. All these commands we would be working with. Okay, with these commands we can basically perform the task of moving hence and forth from foreground to background, background to foreground. Okay, how to control processes using kill command with signals. Okay, how do you control the process with the kill command? There is a command called kill command. Using the kill command, you can basically terminate the process. You can not necessarily only terminate the process, you can even stop the process. That's why I use the term control the process. So you can basically control the processes using the kill command. And for doing various tasks with the process, like you may want to terminate, you may want to interrupt, you may want to hang up the process, you may want to stop the process. Okay, you may want to suspend the process. So for all these things, there are different signals. So using signals, basically you would be controlling the process with the kill command. Okay, so we will be working with the kill command also. Let us work with the processes. PS command, that is a command called PS command. PS command displays the information about the processes that are running for that particular user. So I have logged in as Murali. So for me, in my terminal, in my login terminal, whichever processes are running, that list of process, the PS command would display, right? PS -f. There is an option called -f. So -f option would display the full listing, meaning it would display a more detailed listing. Like it displays more information like UID of the process, PID, then PPID, that is a parent process ID. For every process there is a parent process, right? Okay. C, the CPU time, S time, start time, terminal at which the process is running, there is the terminal allocated to the process, the time, okay, then the time taken for the process to load, then the CMD, the name of the process, all these information it displays, right? There is a command called TTY command that also displays what is the terminal allotted to us. So every login user would be allocated one terminal, and that would have a terminal file name, and all these terminal files would be present in /dev/pts. Okay, so this particular directory would have all the terminal files. So in Unix and Linux everything is a file, right? So even a terminal is a file. The terminal allocated to the user, that is a file. So the terminal file, all the device files, no, they would be located in /dev, right? So terminal also being a device, right? So the terminal that Unix gives to you, the terminal, what is the purpose of Unix providing you with a terminal? So only with the help of the terminal you would be able to interact with the system. Like you have to be provided a dollar prompt, a terminal, the screen, so that you are able to execute you are able to type your commands, you are able to see your output, okay. And then you are able to use your keyboard, okay, your input terminal, that is a keyboard, then the output terminal monitor, okay. So you would be able to work with all these terminal files. So that is basically because the when you are logging into the system, a terminal is provided to you, okay, along with the login shell. The terminal is provided to you, right? Now let us see how do we run a process in the background. Okay, so let me write a script like this. Find df status dot sh. Okay, this is a script which would be printing the df status every interval of time. Okay, what is, so by the way, what do you mean by df? That is a command called df, disk free. So it displays me the disk free status, okay, like the file system, then 1K blocks used, how much blocks are used, how much are available, what is the use percentage, in which file system it is mounted on. So all this information it would display. So basically in a typical development or test or production environment, no, so this is very crucial, how much is available, how much is used. This information is very much crucial to see that our disk, whatever allocated storage space, no, it is not it doesn't exceed. So if it exceeds, then we need to take care of that. Okay, we need to tell the system admin, so that the system admin takes care by doing some disk cleanup operations, like maybe the log files may be more, and then he or she may take a decision to archive the log files, archive and compress the log files, so that your disk space is you get a more free disk space. Okay, so that's the purpose. So for that purpose, this disk free command, df command, would be really very helpful. So maybe system admin decides that okay, every 1 hour he starts he wants to start a background process, where in this background process what it would do, every 1 hour it would display the, maybe it would write to a file the disk file status, okay, disk free status. So he can basically check the file at any point of time, okay, to see the status, what is the disk free status, okay, so that he or she can take appropriate action. So for that the system admin wants to write a script. So let us try to write such a script and help the system admin. Okay, so now I have told you what could be the purpose of such a script, which would generate the disk free status every interval of time. So rather than 1 hour, for our quick understanding purpose, for us to quickly check, okay, the how it gets the file gets updated, we will keep the interval as 30 seconds. Okay, so vi find df status dot sh. Okay, here what I am doing, okay, I am giving a shebang line first. Okay, while true. So what is the meaning of this true? There are two commands, namely true and false. There are two commands in Unix, namely true and false. Okay, the purpose of which is just either to return successful exit status or just to return unsuccessful exit status. True does nothing but just return a successful exit status. Always it would return a successful exit status, and false command would always return an unsuccessful exit status. So when returning successful exit status means what? Storing the value 0 in $? Variable. So while true, so it is something like giving while 1 in C programming. Okay, while 1 will always evaluate to true, right? Similarly, while true, this would always be evaluating to true. So if we want to write some infinite loop, we can always give while true. So this will be an infinite loop, because true will always be true. So this loop would always be executing unless and until we are breaking out of the loop. Okay, explicitly. Otherwise, by the loop itself would keep on be executing. So here what I want to do, df double greater than /tmp / df status dot txt. Okay, then I want to record the time also, right? Date plus percentage d percentage m percentage y. Okay, then underscore percentage h percentage m percentage s percentage h colon percentage m colon percentage s. Okay, double greater than /tmp /df status dot txt. What we can do, maybe if we want to store it in a variable, we can store it. Okay, something df where equal to /tmp /df status dot txt. Now what we will do, wherever we have specified the file name, we will substitute that with the variable name. Fine. $df where, that's all, right? And then I want the script to sleep for 15 seconds. Okay, fine. So what the sleep command would do, sleep command would make the script to sleep for, we go to the sleep state for 15 seconds. So it won't be doing anything, it would just sleep for, it would go to the sleep state. This process would go to the, this is one of the states, this process would go to the sleep state for 15 seconds. After 15 seconds are over, again it will wake up, it will go to the beginning of the while loop, and then it will be evaluated to true. Then df command and date command would be executed, their output would be appended to df where, then again go to sleep for 15 seconds. So every 15 seconds it would wake up and then keep appending to the file, because I have given the appending operator. Okay, appending redirection operator, output redirection operator, but appending to the file. Fine. So this is a script which I want to run in the background, because see this, if you see, this script is non-interactive. Is it interactive? No, it is not at all interactive. Does it expect input from the user? No. Does it display output to the monitor? No. Output it is writing to the file, and input it is getting from the system. So it neither expects input from the keyboard nor sends output to the output terminal, that is a monitor. So this is a good candidate for being run in the background. So let us initiate this process in the background. If you just by chance initiate it in the foreground, okay, let us suppose that you are initiating it in the foreground. Okay, first of all we need to give the execute permission, chmod u+x find df status dot sh. Okay, now /df find, and what is the file it is updating? In /tmp directory df status dot txt, right? So that is a file it is updating. Okay, so I'm just executing it, but by mistake I have executed it in the foreground, right? So if you execute it in the foreground, it won't give you the $prompt, and it is non-user interactive. So there is no purpose of executing it in the foreground. Anyhow, it is not okay, terminal dependent. You could have executed it in the background, right? So how do we execute the script in the background? Let us check that. Now see, it is in the foreground. Now how do we get the prompt? First of all we need to get the prompt, then only we can execute the script in the background, right? So how do we get back the prompt? So the thing is that we need to move the script from the foreground to background. The script has started executing, fine. So I don't want to terminate the script or anything, but I want to move it. So for that, one thing what I can do is that I can suspend this, I can stop or suspend this script. So there is one, there are keyboard shortcuts for sending signals to the processes. So to the script process, to the shell script process, I want to send the suspend signal. So what is the keyboard shortcut for the suspend signal? Control Z. Okay, so Control Z, what it would do? It would stop the script. Now it has stopped the script. So what is the status of the script? The script has now moved to the stopped state. Okay, how do you know how do you list the information about the script? Jobs. There is a command called jobs. Jobs would display the information about the suspended and then the background processes. Suspended processes and the background process, that is the process that are running in the background. Okay, now the script is stopped or suspended, so it displays, and at the beginning it is displaying one ID, right? So that is known as a job ID. So every job has got a job ID. So this has got the job ID 1. So now how do we move the script to the background? So my purpose is that I don't want to terminate the script, but I want to move the script to the background. So how do I do that? It's very simple. There is a command called bg. So using the bg command, you can move the script to the background. But how do you identify the script? You can't identify the script with the name of the script. Okay, that is not an identifier. But how else you can identify? Just now I was telling you about the job ID, right? So using the job ID, you can identify the script. Can you just give one? No. Whenever you want to specify job ID, you need to prefix with 1. So when you need to prefix with percentage. So whenever something is succeeding percentage, then the shell understands that that is the job ID. So then the shell understands that, okay, the user wants to put the job with the job ID 1 to the background. That is what the shell understands. So I give bg %1 enter. So now here let us see, okay, the status of this script. It is now in the running state and it is running in the background. How do you know that it is running in the background? So how do you know that it is running? Because if this script is running, this script should be appending to the file every 15 seconds, right? So how to watch the growth of the file? The file is growing. Okay, the file is supposed to grow because it keeps on appending, means what? The file would be growing, keep on be growing. So how do you watch the growth? Meaning as it keeps on growing, you want to see, okay, what all keeps on getting appended to this file. So I want to see, okay, what is the status of that log? Okay, so how do we know that? So to watch the growth of the file, the tail command helps you. Tail with -f option would help us to watch the growth of tail. It would display from the end. So from the end, tail minus f, it will do what? It will display last 10 lines, and as the file, something gets appended to the file, then that keeps on tail keeps on displaying that information. It will not statically display the current whatever at the time of executing tail, whatever was the last 10 lines. It would not keep that output static, but as if the file is growing, then it would as the file keeps on growing, it will show the updated 10 lines, updated last 10 lines. So not necessarily just tail minus f. In case you can also give tail minus 20f, that is last 20 lines, or 50f, last 50 lines, 100f, last 100 lines. Okay, so but by default, when I just give minus f, it would display last 10 lines, because 10 is by default, right? For head and tail, head by default would display first 10 lines, tail by default would display last 10 lines from the file, input file. So when I just give minus f, it means minus 10f. Okay, then what is the file that the script is updating or appending? df status.txt. okay, let us see. So it is 16, 14, 22. So every 15 seconds though, so it should be growing in the next 15 seconds, like it should show 16, 14, 37, right? Yes, 16, 14, 37. It means that it keeps on appending to the file the updated status of df. See here, if you see the updated status of df would be same. Okay, but if you see in a production server, if you see in a test server, that would make a lot of meaning, right? Because in the production server or in the test server, a lot of applications would be running, and then a lot of users would be using. So it is subject to a lot of change. Applications would be creating so many log files. Okay, so that would be the scenario in a production server. So this script keeps on appending to the file, okay, /tmp/df status.txt. to this file, it keeps on appending the df commands output, and we are able to see that, okay, every 15 second. See, now it is 16, 15, 53. So it keeps on appending, and with the help of tail with the -f option, we are able to watch the growth of the file. Okay, how do we come out of tail command? Control C. So control C would send the interrupt signal. So we have started working with the signals. See, we gave control Z, right? Control Z would send the termination signal. Control Z would send the stop signal, okay, or suspend signal, and control C would send the interrupt signal. Interrupt would terminate. And whenever you would have observed, well, let us suppose that I am creating one file like cat greater than my file, then I am typing something and I want to terminate. What I do? Control D, right? Control D. Control D would send the terminate signal. Control C sends the interrupt signal. So by interrupt signal also we are terminating. By terminate signal also we are terminating the process. But control Z would send the stop or suspend signal. Okay, so these are all the signals that we send to the foreground process, but we will also be seeing the signals that we can send to the background process. Okay, that we can send using the kill command. So next, let us look at the kill command. Okay, so kill. I want to look at the list of signals that are present, that are available. Okay, kill with -L option would display the list of all available signals. -L means list. Okay, so list the available signals. Okay, so it will list the available signals: sig hub, sig abort, sig segv related to segmentation fault. So you look at this, what is it, row by row: sig hub, sig int, sig quit, sig ill. Okay, sig trap, sig abort, sig bus, so on so forth. Okay, sig kill, sig user1, so on. So there are so many signals that are present. Okay, so how do we pass these signals? Let us suppose that my background process, I want to terminate. Okay, so jobs Okay, so I can't terminate this background process by any control Z or control D because it is not terminal dependent process. It is not running on the terminal. So if it is running on the terminal, then I can issue any with the keyboard sequence. I can terminate this process. Okay, but this being a background process, no, how can I control it from the terminal? I cannot control it from the terminal because it is running in the background. So how do I do that? One way of controlling it is using the kill command. Using the kill command, by passing some signal, you can kill the job. Okay, so if we just give so this process has got the job ID, right? Either you can give kill percentage job ID, or you can specify kill followed by the process ID. But for that you need to know the process ID. So how do you get to know the process ID? ps-ef pipe it to grep. Okay, let me grep for find df status. Okay, yes, so this process is running, right? So ksh is running this process, this script. Why ksh is running the script? Because I have given the shebang line, right, wherein I have given user bin ksh. Okay, so what is the PID of this process? This script process, this background script process 4573, and PPID is 3371. Fine. So this script process, the PID is 4573. So with the help of PID also I can kill it. For that, for finding the PID, you can take the help of ps-ef. Okay, so -e means display all the processes that are running in the system, including the user's terminal process. Okay, and including the system daemons, everything. So display all the process. Okay, f means full listing. Okay, even ps-f I told, right? So f is full listing, e means all process. Okay, so now we know the process ID. So it is our choice, either by specifying percentage job ID or just the process ID, we can kill it. Okay, kill, and I am giving the PID 4573. But I have not given any signal, no? I told you that with kill, you would be specifying a signal by which you would tell, okay, how this process has to be terminated, right? So if I don't give any signal, if I don't specify any signal with the kill command, the default signal passed is the term signal, terminate signal. Okay, so the default signal passed is terminate signal. So let me not pass any signal. Let me just try to kill this process with the background process with the process ID 4573, right? Okay, let us see whether this process is still running. No, it has gone to the state terminated, meaning this background process is terminated. Why it is terminated? Because we have passed the term signal. Okay, by passing the term signal, we have killed this process, right? Okay, so we have killed this process with the term signal. Now if you type jobs, no. Okay, this process is not at all there. Okay, just check by giving whether that whether that process is running or not. There is one more way of checking. Okay, like this also you can check. No, it is not now. It is now it is not showing that process at all. Okay, that grep command itself was there when the snapshot of the grep command it takes. That grep command has got that find df status now, so it is grepping for that. It is getting that. Okay, so that process itself is there, grep process. Okay, that is what it is showing, but otherwise it is not. This process is not there. Okay, grep -v grep. If you give like this, nothing will be there. Correct? Fine. So that process is no more running. There is one more way of cross-checking also. What is that one more way of cross-checking? You can just tail. What is the tail? Okay. Now the tail after 15 seconds, is it appending? Okay, 1621. Okay, 1621 is the latest. But what is the time now? It is 1623. So after 1621-23, no, it has not updated. So if you still want it, you can just check it out. So 1621-23. Okay, just wait for 15 seconds. It won't be updated. Okay, it won't be appended. The file won't be appended. Why? Because this script has been terminated. So how we have terminated? By passing the default signal, term signal. Okay, what are the other signals by which you can terminate the script? So we will come to that. Okay, so now let me press Ctrl C and come out of the tail minus F. Okay, now let me run the script once again in the background. Okay, now / find df status.sh. Okay, ampersand jobs. Yes, now it is initiated in the background, so it is running in the background. Okay, ps-ef. Yes, this script is running and it has now got, earlier it got another PID, right? Some other PID. So every time the kernel would be allocating, when a new process is entering, the kernel would be allocating a unique PID. So now it has allocated the PID 4747. Okay, fine. And with this PID, it keeps running. Okay, a process needs a PID for it to run. For it to run in the system. Okay, fine. So now it is running with the PID 4747 and its PPID parent, its parent is having the PID 3371. Okay, that's fine. Okay, so what are the other signals that I can pass to stop it? Okay, see, this is a background process. You can't stop this process by pressing Ctrl Z because this is terminal independent process. So what is the signal you can pass to stop this process? Let us see that. Kill, there is a signal called TSTP minus TSTP. See, if you want to know what are the various signals, just kill minus L you give. Okay, just check, is there any sig TSTP? So you can, while passing the signal, you can avoid that prefix. Okay, the common prefix. You can just specify the suffix. Just check, is there anything like TSTP? It should be there. See, signal number 20. So every signal has got a signal number. So you can specify the signal number also, or you can specify the signal name also. So you can specify minus 20 also, or minus TSTP also. You don't have to give minus sig TSTP, minus TSTP. You can ignore the prefix, that common prefix. Why I am telling common prefix? All these signals have the prefix 6, right? So that you can ignore and you can just specify the suffix. Okay. Now let me pass the TSTP signal. So kill minus TSTP. So sig TSTP will send the stop signal. See, TSTP. STP means stop. Okay. And then what is the thing? Either I told you, either I can specify the PID or I can specify the job ID. Now I am specifying the job ID. But if you want to specify the job ID, you should prefix with percentage. Otherwise, it would understand that as a PID. If you are not prefixing with the percentage, right? Then it will check what is the process with the PID one. That is a init process. So it will give an error. We can't kill the init process. Okay, we can't send any signal to the init process because it is a system initiated process. So we can't control the system initiated process. Only system admin can control them. Fine. So we will get an error, permission denied. Okay, now we have gained %1. So %1 means what? The process with the job ID 1. So and that is exactly this background process. So we have sent the signal. Now let us see what has happened to this process. This process has moved to the stopped state. From the running state, it has moved to the stop state or suspended state. So now this process is stopped or suspended. How did we do that? By passing the TSTP signal. Either we can pass the TSTP signal or we can pass the minus 20 signal. So either way, it would send a stop signal and just stop the process. So this process is there. Now this process is very much there in the system. But only thing is that it is in the suspended or the stopped state. It can always be re-invoked. Okay. So how do we re-invoke this suspended process? Earlier only we saw that, right? How do we do that? By moving it again to the background by BG command. With the help of BG command, we can move. So BG %1 would move it to the background. Okay. Now type jobs. Yes, it has moved back to the running state. Now I want to terminate this process. Okay. For terminating the process, there are various signals. There is one signal is term signal that we saw. Just now we saw some time back. That is a default signal. You can pass the term signal explicitly by giving -term also. Fine. Okay. If you don't pass any signal explicitly, then also it would be term signal. okay, there are other signals also. For example, there is one int signal, int or interrupt. All these signals are what is that, uppercase. Okay, kill minus int %1. So I'm trying to kill this background process with the int signal. Okay, jobs. So by now I have sent the interrupt signal. Next time jobs, no, this process is interrupted. So by sending the interrupt signal, we can kill a background process. Okay. Okay. So now again, let me initiate this background process. /find df status.sh. Oh, sorry. Okay. Now I have to press Ctrl Z. Okay. I am stopping it and kill 9. Sorry. bg %1. Okay, now I have moved it to the background. Okay, it is running in the background now. Okay, now I want to send some other signal. Okay, kill. There is a signal called hop. So that stands for hang up. I want to hang up the process by sending the hop signal. Okay, so %1. Let us see whether the hop signal, the process has respected the hop signal and got terminated. Yes, it has got hang up. Okay, so by sending hop signal also you can hang up the process, meaning you can terminate the process. Okay, jobs, no, the process is no more there. Fine. Then again I have not succeeded by ampersand. Okay, so this is a stopped job. Okay, jobs, stopped job, bg %1. You are putting in the background. Jobs, running, it is running. Now kill minus. Okay, so we have tried with the int signal, we have tried with the term signal, we have tried with the hop signal. Okay, then there is a signal called quit signal, QUIT, capital QUIT. Okay, and then %1. Jobs, yes, quit code dumped. Okay, so quit signal also has terminated the background process. So jobs command, no, there are no jobs running. So there are various ways of terminating a process or killing a process with the kill command. There are various signals that are available. So how do you know which are all the signals available? Let me repeat, kill minus L. So these are the various signals available. So not only shell script. So many of the programming languages, they have way of handling or working with the signal. So what is the advantage of working with the signal? So let us suppose that okay, while the program is running, the user would have okay, send some key sequence, Control Z or Control C or something. So that would in turn turn out to be signals. So when those signals are passed, the program should be able to respond to those signals appropriately. So that, and like freeing the resource or anything. Okay. So for that purpose, or let us suppose that there is some segmentation fault. There is a C++ code and there is a segmentation fault. So when there is a segmentation fault, then some action, some freeing of some resources and all has to be done. Then only the program should be terminated. Let us suppose the programmer wants to take care of that. So 6segv. So he or she can handle that 6segv signal. Okay, there is C signal number 11. So they can handle the 6segv. So for anything that the programmer encounters, for that there is some issue with regard to the pipe. Okay, you know about the pipe, right? We have learnt about the pipe. Sig alarm, okay, sig term, okay, sig user one. So user can have their own signal, define their own signal, and they can use it. Okay, user two. So like that, there are so many signals. So we can work with those signals as appropriate, as required. Okay, so there are here I want to tell you something, one more thing, like there are two signals. Okay, basically a process would would be killed. Okay, by most of the signals the process would get killed. Okay, and but there are certain signals the process can ignore also. Okay, there are many signals the process can ignore also, meaning the process would not get terminated for some of the signals. That depends on what process it is. Okay, but there are two signals which no process can ignore. There are two signals which no process can ignore. See, let me repeat it. A process can ignore some of the signals. Okay, but there are two signals which cannot be ignored by any process. They are the kill signal, that is the ultimate signal, and the stop signal. Kill signal with the signal number 9, and then the stop signal with the signal number 19. So these two signals the process cannot ignore, meaning the process have to submit to these signals. The process would be necessarily, when you are sending the kill signal, whatever may be the process would be terminated, provided you are having permission to terminate that process. Let us suppose that with the kill signal you are trying to terminate some other user's process. No, you cannot do that. With the help of the kill signal, you are trying to terminate the system admin's process. You cannot do that. Your own process, maybe some of the signals they are not able to kill it, but with the kill signal, you are trying to kill with some other signals, if they are not able to kill it. So ultimately you can go for the kill signal, which will surely kill it. Okay, you want to terminate that process because that process is not running properly. It is creating lot of junk files. It is not behaving in a proper way. So right now you want to terminate that process. Okay, so in that case, if no other signal the process is honoring, then you can always send the kill signal. Or there is a scenario wherein just you want to stop the process. Okay, there are two signals to stop the process. One is TSTP, another is stop. TSTP we have seen, right? But TSTP some processes can choose to ignore, but no process can ignore the stop signal. So when you are sending the stop signal, that process would surely be stopped, whatever may be the process, except the scenario wherein you are trying to stop the process for which you don't have the permission. So you are not the owner of that process. That process, if you want to stop, it will not stop even with the stop signal. But your own processes, the process for which you are the owner, yes, you can stop them with the stop signal. So these are the two signals. Similarly, a program can understand, or it can recognize or trap, okay, all the signals. Okay, it can trap all the signals, but not the kill and stop. So they cannot, the program can trap any signal, okay, and take appropriate action, but not kill and stop. Okay, the program cannot trap the kill and stop signal. Okay, so these all concepts we will be continuing in the next session. Okay, and also we will be learning more about the PS command. We will be learning the significance of no-hub command. All these concepts we will be seeing in the next session. So stay tuned for the next session also. For staying tuned to our classes, you can subscribe to our channel, and for getting the notifications, you can click on the bell icon. Thank you. See you in the next class. Take care. Bye bye.